By separating the variables, when you see differential equation of this nature, dy over dx equals to f of xy, that is x and y are function of dy dx. Then separating the variables, that's when you use the method. Okay, let's take down this example. One plus x square dy over dx equals to 1 plus y squared. From here, the first task is to get your differential equation in this form. Then how do we do that? Divide both sides by 1 plus x all squared. Then you have dy over dx equals to 1 plus y squared, 1 plus x squared. Next step, cross multiply. You have dy equals to 1 plus y squared, 1 plus x all squared dx. From here, don't forget, you want to isolate the function of y from x. Then how do you do that? From here, you've gotten dy to be this. What you can do here to isolate the function of y from x is to multiply both sides by the reciprocal of 1 plus y squared. Meaning multiply the left hand side by 1 over 1 plus y squared. Also multiply the right hand side by 1 over 1 plus y squared. By doing that, we have dy times 1 over 1 plus y squared, equating that to 1 plus y squared. Repeating all what you have here, then multiply. One over 1 plus y squared. Then doing your algebra, this can cancel this. You are left with dy over 1 plus y squared equals to dx over 1 plus x squared. And from here, we've been able to differentiate, we've been able to isolate the function of y from x. Then the next thing to do is to integrate both sides. Integrate both sides. From here, when you integrate this, you have tan inverse of y. Tan inverse of y. Recall, from standard integral of 1 divided by 1 plus x squared dx is equals to tan inverse of x. So when you have integral dy divided by 1 plus y squared, applying this, you have tan inverse of y equals to integral dx over 1 plus x squared. And how do we solve this? Applying the idea of differentiation or the understanding of differentiation by integrating this. Consider the right hand side. Integral of dx divided by 1 plus x squared. Solution. Let u equals to 1 plus x. Du over dx equals to 1. Cross multiply. We said du over dx equals to 1. Cross multiply. You have du equals to what? Dx. So therefore, this integral, you have integral dx is already du, you have du, and 1 plus x let u equals to 1 plus x. Anywhere you see 1 plus x, you put your u, and you have u squared, which is still the same thing as integral u raised to the power of minus 2 du. From fractional index law, from your indices, you have this. So let's integrate that. Integral u raised to the power of minus 2 du. From the basic rule of integration, add 1 to the power, then divide it by what you've added. Then this is u minus 2 plus 1, and minus 2 plus 1 simply means minus 1. That's okay. Let me work that out. Minus 2 plus 1, this is u minus 1 over minus 1. Abi? Then from here, you have integral, okay, from u raised to the power of minus 1 divided by minus 1 simply means minus this. Abi? Then from here, integral dx divided by 1 plus x all square is equals to what you differentiated here, and which is this, what you integrated rather, which is minus u minus 1. And knowing your u to be 1 plus x, 1 plus x raised to the power of minus 1, which is equals to what? 1 divided by negative 1 divided by 1 plus x. And from here, you've integrated the right hand side. Then substituting the value you have tan inverse of y equals to minus 1 divided by 1 plus x. Then you are done. This is your differential. This is your when you solve the differential equation, this is what you get. And from here, if there's any possible evaluation or simplification you can do, you can get a y. In some cases, when you got this, you can go further and get the y itself. But for this question, plus c. For this question, this is the solution to that. The next example. Okay. From here, when we have question like this, the question we need to ask ourselves is this by direct, what method will I use? The first one is by direct integration or by separating the variable. And we said earlier that when we have our differential equation of this form, we use by direct integration. When we have differential equation of this form, we use by separating the variable. Meaning, for this question, our differential equation is of this form. Hence, we go with what? By separating the variable. Then what I need to do here is to do my necessary algebra so as to put the question given in form of this. Then by doing that, I need to get rid of x, which is here. Divide both sides, divide all through by x. You have dy over dx equals to y over x plus xy over x. Then from here, you have y over x plus y equals to dy over dx. Okay? Dy over dx equals to y open bracket 1 over x plus 1 plus multiply dy is equals to y open bracket 1 over x can be written as x inverse plus 1 dx. From here, isolating the function of y from x. And how can you do that? You can simply do that by multiplying both sides by the reciprocal of y. 1 over y, for the left hand side, 1 over y times dy equals to y open bracket, this multiplied by the reciprocal of y, then this cancel this, then you have dy over y equals to x minus 1 plus 1 dx. Integrate both sides. Integral dy integral dy over y equals to integral 1 over x plus 1 dx. From here, when you integrate 1 over y, you have in y equals to, similarly integrate 1 over x in x plus integration of 1, integral 1 is x plus c. From here, ln y minus ln x, take ln x to this side, ln y minus ln x equals to what? X plus c. From here, from your logarithm, ln open bracket y over x equals to x plus c. Don't forget, whenever I'm giving a differential equation, my interest is to find the function itself. So the function itself in this case is what? Y. So from here, to get rid of ln, take exponential to both sides. You have exponential y over x equals to exponential x plus c. Exponential cancel ln, we are left with this. Then you have y over x equals to exponential x plus c. From logarithm or from indices, you have y over x equals to exponential x multiply by exponential c. Okay? From there, call this equation 1 or call this 1. From 1, assume, since we know that exponential raised to the power of c is a constant, let's assume or let's make the suggestion that exponential c to be a or any value of your choice, but I'm going with a here. So I'm having y over x equals to exponential c dot a. From here, cross multiply. Y equals to exponential c times a times x. Then from here, y equals to ax exponential c. And this is the solution. This is the function of y. When you are given the differential equation, when you integrate, this is what you get for y. Alright, okay, stay tuned for more videos. Like, comment and subscribe. If you enjoyed the video, don't forget to share your thoughts in the comment section. See you in the next video.